Good evening. Today I'll be discussing the effects of vitamin C on tumor growth in plants. Hello, my name is Rebecca Shields. I am a senior in the graduating class of 2023 at Chatham High School. After graduation, I plan to attend Virginia Tech, where I will major in bioscience with the hope of receiving my degree in pediatrics. My sole reasoning behind the choice of this experimentation process has been my love for the agricultural industry, specifically because my entire life has been surrounded by a farm right here in the center of Pittsylvania County. After learning that agriculture was the topic I wanted to study, I began doing reviews of literature, and I discovered that over 10% of the world's population is subject to food scarcity. And because pesticides are causing more harm than health, I wanted to discover a natural alternative to this issue. The number one leading cause in food scarcity and in the decline of vegetation and plant growth is plant galls. Plant galls are tumor-like growths that grow on the stems and roots of plants, and they attack the central nervous system. Researchers wanted to learn more about how these plant galls affected the nervous system overall, so they administered specific types of bacteria to the plants and then observed the tumors as they grew. A pesticide's pure purpose is a vaccination method for plants. However, once again, like I said, they are causing more harm than help. They are now causing negative environmental effects because through runoff they are seeping into waterways, and through the consumption of animals, they are killing off local organisms. Vitamin C is also known as ascorbic acid. It is a biostimulant, which means through the process of biofortification, it can be taken from one thing and placed into another. Experimenters wanted to determine if you were able to take vitamin C and place it in other plants. And after they did so, they were able to determine that it increased the lifespan of other plants by several years. This led me to my research question, which is, does vitamin C affect tumor growth in plants? I hypothesized that overall, if vitamin C was administered to plants with the tumor-growing bacteria, then it would overall limit the tumors in these plants. Thus, stating my null hypothesis meant no difference would occur whatsoever. The variable that I changed throughout was my vitamin C, which I then compared to a control group of pure water, and I measured the amount of tumors that grew throughout. I left the amount of sunlight, the amount of water, type of bacteria, type of vitamin C, all the same. To elaborate a little more, I used chrysanthemums for the type of plant because they have proven to grow tumors. And I was performing this experimentation process in the months of fall. I used Nature Made's vitamin C gel capsules because I did a water concentration through these hydroponics. And I used Agrotubifasciens bacteria because it is the most popular proven tumor growth stimulant out there. I had a sample size of 30, which I then divided into two groups, 15 pure water and 15 vitamin C. To begin my procedure, it began at Hamer Garden Center, which is where I gathered my 30 chrysanthemums. I then brought them home and exposed them to a sunlit room for 24 hours in order to allow the plants to adapt overall. I then, after review of the literature, determined that they needed to be wounded at the stem to administer my bacteria, because the number one cause of tumor growth in flowering plants specifically is through the cause of pruning, which is the removal of dead and decaying leaves, limbs, and flowers. I then absorbed and administered my Tumifasciens bacteria to the open wound site. And I watered when necessary because chrysanthemums are a very high maintenance plant, which means that if you overwater them, they can drown, and they rarely absorb water very quickly. After a 30-day process was up, I then collected and counted my tumors, and I performed my statistical analysis test. My statistical analysis test was performed through a t-test and an Excel spreadsheet. I chose a t-test because I was comparing two separate variables, and I was able to conclude that at the significance level of 0.05, the null hypothesis was rejected because my p-value was 0.003. As you can see in the graph above, I also calculated averages as well to give an easier visualization of how the two groups ended up calculating. My vitamin C group averaged about 9 tumors per plant, whereas my pure water group averaged about 24 tumors per plant. My conclusion stated that at the 0.05 level of significance, there is sufficient evidence to conclude that tumor growth is limited when the plants are administered vitamin C concentrated water. However, some limitations did occur throughout my experimental process, specifically the plant species. While I did choose chrysanthemums, I had 2 separate species, one garden and one Belgian, in order to compare the two. Belgian mums have a thicker stem like cover crops, whereas garden mums have a thinner stem. And I was able to prove that because of that thicker stem, the scalpel did not open up the central nervous system like it should have, and the Belgian mums did not end up growing tumors, whereas the garden mums did. The potting size also has to do with it. The Belgian mums came in a smaller potting size with less room for tumor growth. The reasoning for my outcome began with my plant type. I chose a plant that I knew overall would grow tumors. Then the concentration amount. After my review in the literature, I determined that 300 ppms, which is similar to milliliters, would be too much of a concentration, whereas 150 would be too little. I had to end up cutting the gel capsules in half, which averaged about 250 ppms, along with the dilution of the water concentration. It provided a perfect amount to water the plants with. And then the vitamin C effectiveness. I chose a vitamin that was an immunity booster in humans because I believed it could boost the immunity in plants as well. Implications towards the future begin with the efficiency in agriculture. Once agriculturists and farmers are able to determine how to limit the amount of tumors, it can create prosperity throughout the agricultural industry, which can then limit the amount of food scarcity that occurs worldwide. It also protects the ecosystem because now water can become purified since a natural stimulant is going into it instead of man-made. Also, it will not harm animals when they consume this form of vegetation as well. And it's also economically proven because it is cheaper for farmers and agriculturists to purchase to place on their crops, whereas vitamin C can be taken from one plant and placed into another, and farmers are able to do it themselves. Future research begins with a vitamin variety. If I could perform my research again, I would choose a wider variety of vitamins. Beta carotene, which is vitamin A, has already been tested on tumor growth, and now vitamin C has. But I would love to see how vitamins B, D, and E would affect tumor growth in plants. I also believe that bacterial diversity is important because agrotumefactions, while it is the #1 leading cause in tumor growth, it is not the only form of bacteria that does grow tumors in plants. And then an elaboration of crops. Throughout my review in the literature, cover crops were the main crops used. However, since I was in autumn months and because of a limitation to my access in the plants, I was not able to purchase corn or wheat. I was able to take away botany experience from this, which is important to me because I'm going into a biological field, and I was able to discover the anatomy and the characteristics of these plants. I learned leadership skills such as responsibility and accountability that I will be able to take with me into college and the workforce. And I also learned an elaboration of environmental poverty, which I did not realize was occurring right here in our own backyards. That food scarcity was occurring throughout the agricultural industry. I would like to thank my parents overall for assisting in the purchasing of these products, and my Piedmont Governor School teacher, specifically Ms. Long, for her assistance throughout the research process and my literature review. I would like to thank Ms. Dillon for her assistance in the inoculation of the bacteria and the administration to the plants. And then I'd like to thank Ms. Hardy for her assistance in my statistical analysis testing. Thank you for your time, and are there any questions? Yes, Dr. South.
You may have said this, but can you tell me a little bit more about how you applied the vitamin C to the plants?
Dr. South asked how I applied the vitamin C to the plant. I took a watering can and I filled it all the way up. And after doing my review of the literature, I did conclude that 300 ppms was too much. I believe it was about 500 ppms in a vitamin C gel capsule, which then had to be divided in half to give me about 250. And once administering it to the water, I just punctured a hole and only squeezed about half of that vitamin C into the can, and the water diluted it as well. So it would cause an effect, but it would not have too much harm to the plant overall.
Thank you.
Mr. Taylor?
Yes, how much time between the inoculation of the tumor-causing bacteria did you let go by before you did your tumor count?
So Mr. Taylor asked, after the inoculation period of the bacteria, how much period of time did I let go by before I counted the amount of tumors? And after inoculating the plants with the bacteria, it was a 30-day process before they were removed from the pots and counted.